All right, here we go with another exciting adventure of integrals and inverse trigonometry integrals and things like that. Let's take a peek ahead about what we're doing is, okay, we're going to be taking some derivatives and some integrals and a little bit of limits, but it looks pretty short altogether. So again, I provided a sheet here. This is, again, can be found in the beginning of the book. So there's some integrals, some inverse trig integrals, some derivatives, and things like that. Okay, so let's go ahead and get started. We are to be taking a derivative of this, a derivative. Okay, so let's go ahead and remind ourselves what the derivative of an inverse tangent is. And that one is easy, where you can sit back and get a tan. And so what that is the derivative of a tangent, dx, of a tangent, inverse tangent, is 1 plus u squared 1 u prime. Okay, so that is what our tangent is. And so let's go ahead and kind of start thinking about what u is and what u prime is and that sort of thing, and that'll really kind of help us out. All right, so we see u in this situation is 1/3 x. So that means u prime is going to be 1/3, and u squared is going to be 1/9 x squared. X squared. So something like that. Okay, so let's go ahead and take the derivative of this problem right here. So this implies that u prime, or dy dx, I should probably say, dy dx, the derivative, is going to be equal to, so 1/3 is just along for the ride, because that's there, it's just along for the ride. And the tangent portion of this is going to be 1 plus u squared so 1/9 x squared, and the top is a u prime, which is again 1/3. So this is 1/3, 1/3. This is technically on top. Okay, so let's go ahead and start kind of thinking about this. I'm going to think about this denominator, and I'm going to factor out, in essence, a 1/9. So this is going to be 9 plus x squared as a denominator. And right now, this numerator is 1/9 right now. So I have this numerator and denominator set. Notice how the 1/9 simplifies with the denominator. So this ultimately will be 9 plus x squared under 1. So that's what that should be. I don't know if I have that represented on the answer key or not. Yeah, I do. So better than I thought. So that's how that works out. All right. So let's go ahead and again remind ourselves what the heck the derivative is in the first place. And so the derivative of cosecant, inverse cosecant, is similar to a secant. So this is going to be absolute value of u squared minus 1 underneath 1, but because it's a it's a negative with the u prime. Okay, let's see the pieces. So let's go with u in this situation is 1/x. So that means u prime is going to be negative 1x to the negative 2, or aka x squared underneath negative 1. And u squared is going to be 1 over x squared, or aka x to the negative 2. However you need to look at it, you have that ability. Okay. So let's go ahead and make these substitutions, make this derivative happen. So this is going to be u, so that's 1 over x. I'll just write it where it is. So 1 over x, x squared minus 1 underneath negative 1, u prime being negative 1 over x squared. So this is 1 over x squared and numerator. Okay, so a lot of cleanup stuff going on. All right, so the first and foremost, I'm going to work with this inside square root. I'm going to get a common denominator of x squared. So this is 1 minus x squared, and that has a common denominator of 1 over x squared, which I'm going to GCF out. So because this is in the inside of a square root, I can GC out a 1 over x. Okay, so that joins forces with the 1 over x that is already out there. Okay, the 1 over x that is already out there. And so ultimately, this denominator is 1 over x squared, square root 1 minus x squared. Okay, so that's what the denominator is. Notice how that directly simplifies with the numerator that is currently there. So this ultimately will be 1 minus x squared underneath 1. If it wasn't for algebra, everything would be easy. Okay, I can worry about the square root portion here. That's a big time chain rule thing going on. Let's focus our attention on the cosine that is going on here, or the inverse cosine. So I know that the derivative of a inverse cosine is 1 minus u squared underneath 1, because it's co, u prime. So let's just worry about the cosine just right now, and then we'll worry about the rest of the problem here in just a second. But let's handle our business with the cosine. So what I see is u is equal to x. That means u prime is equal to 1, and that means u squared is equal to x squared. So as far as the cosine is concerned, this cosine directly is going to be negative 1 minus x squared square root. And that's what the cosine directly is. I'll kind of put that to the side because I'm sure that there's probably a lot more math to come in this problem. Okay. So now I'm going to focus my attention on this x square root of 1 minus x squared square root. And I'm going to take the derivative of this. I know it's probably been a while since we've taken derivatives using the product rule, but remember this is u times v, so it'll be u prime times v plus v prime u. Okay, so here we go. So this is going to be 1 times 1 minus x squared to the 1/2 plus, leave the first part alone, And then this is going to be 1/2 1 minus x squared to the negative 1/2 times the chain rule of negative 2x. All right, so I see 2 and a 2. X's are going to join forces. It's going to turn into a minus. So this is a negative x squared over the square root of 1 minus x squared. And this is just straight up the square root of 1 minus x squared over 1. So getting a common denominator of 1 minus x squared, this is going to turn into a regular 1 minus x squared that's already there. And this is going to be 1 minus x squared square rooted. And so this ultimately is negative 2x squared plus 1 all over 1 minus x squared square rooted. That's ultimately what the derivative of that x to the 1 minus x squared to the 1/2. Okay. So let's put it all together. So the derivative of this thing is going to be equal to negative 2x squared plus 1 all over 1 minus x squared square rooted minus a negative, so it'll be plus 1 minus x squared square rooted, what do you know, fortuitous, all over 1 because I just subtracted. And so, I see what's going to happen here. So this is 2 minus 2x squared. We already have a common denominator, so we don't have to worry about it, which is 1 minus x squared square rooted. Taking out a 2, this is 1 minus x squared. And then this is 1 minus x squared. Okay, so in essence, this is to the first power, this is to the 1/2 power. So notice how the polynomial is exactly the same. So we can take the top minus the bottom, which will come out to be 1 minus x squared to the 1/2 power, aka the square root. So this is going to be 2 square root 1 minus x squared. Okay, on to integrals. So what I see in this is most likely a u squared minus a squared square rooted underneath a 1. So this is going to be the integral of that du. So what I recognize this as is this is the inverse secant. So this is going to be 1 over a inverse secant of u over a plus c. Okay, but because it's a definite integral, I don't have to put the plus c, but I do have to evaluate this. And also because this is a definite integral, I'm going to redefine the limits. So once I go to this u, I don't go back to the x. All right, so substitutions that I currently made is this. A squared, I made 1. That makes a 1. U squared, I said, was x squared. So that makes u equal to x and du equal to dx. I really don't have any funny business to work out there. It's all looking like it's going to cancel stuff out. All right, so from this u, I'm going to reevaluate negative square root 2, which stays negative square root 2. And negative 2, again, which stays as negative 2. But I technically reevaluated it, so I'm going to go to a u, and I'm going to leave it as the letter u. All right, so here we go. Going back to the original problem, doing all the substitutions that I made. So negative square root 2, negative 2. This is u square root u squared minus a squared all underneath 1 dx is du. And so this is working out exactly perfectly to the way that I needed it to. So I can actually now go ahead and make this thing. So A's are going to turn into the number 1s, U's are going to stay the letter U. Okay, so this is 1 over A, so that's 1 over 1, inverse secant, U over A, which is U over 1. This is being evaluated from -2 to negative square root 2. So there are the 2 math problems that I actually need to do to figure this out. The first one being, where is the secant, inverse secant of negative square root 2? And so that makes the regular secant inverse, no, excuse me, the regular secant, the secanting both sides, of theta equal to negative square root 2. Secant is the inverse of cosine, so I'm going to take the inverse of both sides, so that means cosine is equal to negative 1 over square root 2, or aka negative square root 2 over 2. So this is, where is the x coordinate? A negative half, and that would be there, which is 3 pi over 4. Okay, so that's one math problem. The other math problem is, where is the inverse secant equal to negative, or excuse me, not where it's equal to negative 2, but when is the inverse secant of negative 2? So that makes the normal secant of my angle equal to negative 2. Secant is an inverse cosine, so I inverse both sides, or I reciprocal both sides. And so this is going to be negative 1/2. And so where is the x coordinate? Really, really small. It's right up there at 2 pi over 3. Okay, those were the 2 math problems that I needed to do to set myself up. Just harness both of these. Make them smaller. Okay, so this is now equal to 3 pi over 4 minus 2 pi over 3. All right. Okay, looking at number 5, I'm kind of recognizing this as an a squared plus a u squared, no square root underneath 1, or again, I'll worry about the x here in just a second. And so if this is true, the integral of this is going to be 1 over a inverse tangent of u over a plus c. Plus c. Again, because this is a definite integral, the plus c is not going to be there. And because it's a definite integral, as soon as I turn this thing into a u, the u will stay the u, the a will revert back to what it once was, but the u will stay the letter u. All right. So making some basic substitutions and just kind of drawing how I made my decisions thus far, anyways, I should say. Okay, so what I made a squared is I made a squared 1, that makes a 1. I made u squared equal to x to the 4th, that makes u equal to x squared, and that makes du equal to 2x dx. Okay, there is some funny business going on here. So what I'm going to do is I'm going to manipulate this, and I see that dx is equal to 1 over 2x du. Okay. I don't think I have to manipulate the x into some version of u. I think this will take care of everything I need to take care of. All right, the other thing that I need to do is I need to reevaluate this. So 1 is still 1, and 0 is still 0. Okay, these are all the substitutions that I need to make into the very original equation. All right, so the very original equation is now going to be the integral from 0 to 1. Those are substituted. Okay, x, I don't have a substitution for that. And then I have 1, which is a squared, x to the fourth, which is u squared, dx, which is now 1 over 2x du. Okay, so here's where I turn my equation into what I want. The x's cancel, and this 1/2 is coming out. Now it's exactly the formula that I needed it to be. So this is going to be equal to the 1/2 that I had to take out, and now it's all this tangent problem. So it's 1 over a inverse tangent of u over a, and then again plus c isn't there because this is a definite integral from 0 to 1. All right, so the two math problems that I have to do. The first one, what is the inverse tangent of 1? So that makes the tangent of an angle equal to 1. And so where is the sine exactly the same as the cosine? That's at pi over 4. They're both square root 2 over 2. So at pi over 4. And the other math problem is what is the inverse tangent of 0? So that means what the tangent of some angle is equal to 0. So where is the sine equal to 0 and the cosine equal to, I'm assuming, 1, and that is at 0. Those are the two math problems right there. So this is going to be 1/2 of pi over 4 minus 0. And so this is going to be pi over 8. All right, so here we go. So nice, play it twice. This is a squared minus u squared square rooted underneath 1. So this integral, if this is true, is going to be inverse sine, no 1 over a, just inverse sine of u over a plus c. Let's go ahead and make our substitutions. So a squared is 1, that makes a 1. U squared is equal to 4x squared, that makes u equal to 2x, and du equal to 2 dx. Okay, careful, careful, careful. So this is going to be dx is equal to 1/2 du. Okay, knowing all of this, let's go back to the very original question and just make basic substitutions of things that I just created. So the original equation is now going to be the integral. 1 is a squared, 4/8x squared is u squared. 1 is still 1. dx, however, is now 1/2 du. So what I need to do to make the equation match is just bring out that 1/2. Okay, but if I do that, we're good to go. All right, so this is going to be 1/2 inverse sine u over a, which is 2x over 1. And because this is an indefinite integral, it goes back to the x. I'm not going to leave that as the letter u. If it was a definite integral, I'll leave it as the letter u. Plus c. Okay, looking at this one, I'm assuming this is u squared minus a squared. Quadruple check this one. So yeah, we're going to have square roots and stuff like that. U squared minus a squared underneath 1, so the integral of that is going to be 1 over a inverse secant of u over a plus c. Okay, so let's make our immediate substitutions. I made my a squared equal to 4. That makes a equal to 2. I made my u squared equal to 5x squared. That makes my u square root 5x. Or I guess it should be x, 5, whatever. And then du is equal to root 5 dx, morning, morning, morning. So this is going to be dx is equal to 1 over root 5 du. Okay. So these are all the substitutions that need to be made. So again, we go back to the very original question and just make these substitutions. So integral x is, x isn't something easy, so let's go ahead into this x. X is equal to 1 over root 5 u. All right, now let's go ahead and make these substitutions. So x is again 1 over root 5 u. 5x squared is my u squared. 4 is my a squared. And dx is now 1 over root 5, which is technically the numerator, du. So I have a numerator canceling a denominator and matching up perfectly to the equation that I needed to create. So this is all good, no extra pieces. So this is going to be 1 over a inverse secant of u over a. Let's see. All right, so okay, so I'm seeing this is a squared plus u squared. Again, I'll worry about the numerator here in just a minute. So this is an integral du, so this is going to be the inverse tangent. So 1 over a inverse tangent of u over a du. Or excuse me, plus c. But because, again, it's a definite integral, I'm not going to get the plus c, and u will remain the letter u upon final calculation. Okay, let's go ahead and deal with our substitutions that we need to make. All right, so I made a squared equal to 1. That makes a equal to 1. I made u squared equal to sine squared x. That makes u equal to sine x. And that makes du equal to cosine x dx. Okay, there's a bunch of weirdo stuff going on here. So I am going to immediately solve for this dx. So dx is a 1 over cosine x du. I don't think I need to solve for x, but I would take the inverse sine, but I don't think I need to. I don't see any individual x's showing up. All right, so I do need to reevaluate my limits, which is going to be pi over 2 and negative pi over 2. So sine of pi over 2 is, sine is the y-coordinate, and the y-coordinate at negative pi over 2 is negative 1. Okay, so I can substitute for pretty much everything in this equation except for this numerator right here, but hopefully it's going to drop or simplify in some version. Okay, so here we go. This is going to be the integral. Negative pi over 2 turns into negative 1. Pi over 2 turns into 1. I don't know about that numerator just yet, so that will stay what it is. And then 1 is a squared plus sine squared, which is u squared. Dx is now cosine x on the bottom. 1 du. Okay, so it did enough. It didn't do everything, but it did enough. It got rid of that cosine, so I'm able to drag out this 2. And now the formula is exactly what I needed it to be. All right, so 2 got brought out, and so now this is going to be 1 over a, so that's 1 over 1, which is 1, inverse tangent, u, which again is going to remain the letter u, over a, which is 1, and then this is getting evaluated from negative 1 to 1. So there are 2 math problems in which I have to do. First one being the inverse tangent of 1. So that makes the tangent equal to 1. So where's the sine? The same thing as the cosine. That occurs at pi over 4. Another one is the inverse tangent of negative 1. And so that means the tangent of my angle is going to be equal to negative 1. So that means the sine and the cosine are the exact same thing, but opposite signs. So that's going to occur at negative pi over 4. Okay, so putting this all together, this is pi over 4 minus negative pi over 4, so that's pi over 2 times 2, so this is going to be pi. Okay, L'Hopital's rule. I do a pretty good explanation on the answer key. Let me give you a quick definition of L'Hopital's. Okay, if I take a limit as x goes to something, I don't really care what, and I'll call this the top f of x and this bottom g of x, okay, of some fraction, okay? If the limit of the numerator is the same thing as the limit, okay, of the denominator, and that is equal to 0 or positive or negative infinity simultaneously, okay? Probably say or. Okay, then, okay, if the limit of the top is equal to the limit of the bottom, and it's either equal to 0 or plus or minus infinity, got a combination of the two. But if that exists, then that implies if then the limit as x goes to a of f of x over g of x, so the limit is equal to the limit as x goes to a of f prime of x over g prime of x. That's L'Hopital's rule. So if I get 0 over 0, infinity over infinity, or negative infinity over negative, or just any versions of infinity, then I can use L'Hopital's rule, and that means take the derivative of the top and the derivative of the bottom and reevaluate. Okay, so right now, let's see if this thing applies. Okay, so what I see currently, so the limit as x goes to 0 of inverse sine x. Okay, so this is in essence asking what is inverse sine of 0. And so that means sine of some angle is equal to 0. That means the angle is equal to 0. So I also notice as x goes to 0 of the denominator is equal to 0. Pretty simplistic. So this is a situation where the limit of the numerator is equal to 0 and the denominator is equal to 0, like 0 over 0. So this applies for L'Hopital's. This applies L'Hopital's. So L'Hopital's says now this limit is going to be equal to the derivative of the numerator and the derivative of the denominator. And then we can reapply. So the derivative of the numerator is 1 minus u squared underneath u prime, which is 1. The derivative of the denominator is 3x squared. So this problem is now transformed. So this problem is now equal to the limit as x goes to 0 of, I'm going to keep it, I'm not going to simplify stuff here right now. This over 3x squared. So now what I'm going to do is I'm going to evaluate the limit. So the limit of the numerator is 1. The limit of the denominator is 0. Now, these, even though a 0 comes out of this, they're not equal. It's not 0 over 0 or some versions of infinity in both the numerator and denominator. So this ultimately is getting an answer of 1 over 0, which is infinity.